Math 1, Unit 2, Practice 1.2. So, taking a look at some intersecting graphs and dealing with those. Now, we've got to remember we're using this function notation. We can see it around here. Okay. Just a reminder, when we're dealing with function notation, we usually have a letter and then a variable in parentheses. And typically, it ends up being equal to, something that we're familiar with. Okay, so the way to remember this is simply the name of the function. Okay, so that's why sometimes we have f or g, and those are the two most common we use. If we needed more, maybe we'd do an h or something else. Okay, this represents our input. Okay, so this together, f of x, represents an output. We're saying what's our output, what's our result if our input, if our x value is this. Okay? Then after it we actually have our function. Okay? Our relationship, our pattern. Okay? So, when they're talking about this, given that we've got these two graphs, f of x and g of x, okay? What is the value of f of x minus g of x where the two graphs intersect? So in other words, they're saying we've got this graph here, and we've got two lines going on, okay, and they're intersecting at some point here. And this would be like f of x and g of x, the outputs. This would be the inputs here. So they're saying if I take the y value of this point of f of x minus the y value of this point g of x, what answer am I going to get? Well, if they're the same thing, anytime you do the same thing minus itself, 5 minus 5 is going to be 0. 4 minus 4 would be 0. 3 minus 3 would be 0. You get the point, right? So f of x minus g of x is going to have to be 0 when they intersect, okay? That really only is the case when they intersect. Okay. Now it says if you are using the graphs, once again, to estimate x, where f of x equals g of x, and you see that the graphs cross at two different points, how many values of x should you attempt to find? So now let's say, for example, we've got a different graph here, and let's say we've got an exponential one, and we've got a linear one. So they're saying, okay, now we cross in two different spots. Okay? And you're trying to figure out where x is. Well, just like the y values were the same where they cross, these x values are going to be the same for both of them, right? Because they share that same point, that same x and y. So the x's are going to be the same, so how many different x's should you find that are the same? Well, there's going to be 1, 2. So that's all it wanted you to come across with, is saying you would try to find two x values. Just like if it crossed a third time, you'd look for 3x values. If it crossed 4 times, 4x values. If it only crosses once, 1x value. If it never crosses, no x value. Okay, that's all it wanted you to say. It's asking these questions in a really weird way. So, if you are trying to estimate the value of x where f of x equals g of x using a table of values, and all the values for f of x minus g of x are positive, what does this imply? Okay, so they're saying we make a table, and because we've got two functions, we kind of extend our table. And they're saying, okay, you've got this function here, and they're saying, and I'm just throwing out these values, I'm just guessing them, but they're saying f of x minus g of x is positive, okay, which would imply that f of x is greater, so g of x would have to be like, something like this. Okay, so what does that mean? Well, it means f of x is bigger, right? It means that they're not intersecting, because if they were intersecting, they'd be 0. Okay? And if they were intersecting, at one point, f of x here and g, if they intersect, the g of x one is going to be bigger eventually, so we'd end up with a negative number. The fact that f of x is always positive tells us it's something more along the lines of this. And I think the visual helps. That if it's always positive, that g of x is always going to be lower than f of x, because this minus this is always positive. Okay, so these numbers are always going to be bigger. Okay, so what would it imply? That f of x is greater than g of x. Okay, that's the way we could write it mathematically. Alright, number 4. Well, using a table of values to estimate the value of x where f of x equals g of x, you see that there are 3 sign changes in the f of x minus g of x column. How many solutions for x can you estimate? Okay, so sign changes means that here we had positive, right? So in other words, they're saying then, if we keep going on this table, okay, these would all give us positive results of the f of x minus g of x. Okay, so then let's say things change and we get, so the g of x is bigger, which would make these negatives. Okay, they said 3, so we need to change one more time. So here's some example numbers. So now f of x is once again bigger. So what does that mean? Okay, well, it means graphically, we use this example. Okay, it means f of x here, the green one, is bigger. Okay, then when we hit that sign change, it goes under, and so g of x here would be bigger. Then that sign change again means that f of x is bigger as well. So it means there's at least 2 solutions. Okay, meaning 2 times that they intersect. Okay, that's what it's going at here. And I know these are very complex ideas and concepts and ways to understand it. Okay. All right. Number 5, estimate the solutions to the following system by graphing for 5 and 6. Okay, so the idea here is that we want to graph our equations. Now, they're both in slope-intercept form, so we have our starting number, and we know how it's growing. Okay, 2 over 1, so it's going up 2 to the right 1, starting at 5. So we go up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1, or down 2 to the left 1. And I can keep making my points. We'll call this good for right now. Okay, so there's f of x in the red. Now g of x, we've got a plus 1, so we start at positive 1. And then our slope is we're going down 1 to the right 2 because it's negative. So down 1 to the right 2, or up 1 and to the left 2. That one should actually be a little lower. Okay, so if we draw our lines, and this is the tough part about graphing. Okay, where would we estimate this to intersect? Probably pretty close to right there, which looks like has a y value of 2 and an x value of negative 1/2. Okay, something like that looks to me like that's, it says estimate, so we don't have to find it exactly, but that's kind of where we want to go. Alright, now we're going to do the same thing for number 6. Okay, we're going to try graphing this one. and estimating where it is as well. Okay, so now we've got an exponential, geometric pattern, and a linear. So my slope here would be 1 over 1. We'll graph this one first. Okay, alright. So we start at positive 4, and the slope of x, or 1x, would be 1 over 1, so we go up 1 to the right one each time. Up 1 to the right one. So it's looking something like this. It's not exact because I've obviously drew the graph myself. Graph paper would be the best idea here to help with this kind of stuff. We'd also go the same pattern back. Okay? Then, let's see. Hold on. Try to graph this way a little better. Now, our exponential one, 3 to the x, that's like 1 times 3 to the x. This is our y-intercept at 1. And then we're times them by 3 as we go up. So at 1 we'd go up to 3, at 2 we'd go up to 9, and then at 3 we'd go up to 27. Going backwards, we'd go down by a third, so we'd be at like 1/3, a little higher probably than that, 1/3, 1/9, 1/27, 1/81st, so it looks something like that, and this one would look something like this. So now it's crossing twice, right? So we've got right here, and we've got right here. Well, down here, it's going to be a really small number. It'll end up being -4 for the x value. The y value would probably be around 1 over 81, or something close to that. Okay, maybe something a little above that, but I would estimate with that one. Okay, that would be that point. The second point, okay, looks like it's closer to probably 2, like 8, and those are just estimates. Okay, normally we use better methods to help us get that. Alright, 7 says use a table of values to estimate the solutions of the following system on the interval -3 is less than or equal to x is less than or equal to 3. Alright, so what that interval means is we're starting at -3. We're making our table from -3 to +3. Okay, that's what that interval means. So then I've got to do it twice, right? I've got s of x and r of x. Okay, so this one we just plug some numbers in. 2 to the -3 plus 1. Okay, 2 to the -2 plus 1. And those are kind of harder ones to deal with, so it might be easier if we did the numbers we know. 2 to the 0 plus 1. 2 to the 0 is 1, 1 plus 1 is 2. Okay, 2 to the first plus 1. 2 to the first is 2, plus 1 would be 3. Okay, then 2 squared plus 1. 2 squared is 4, plus 1 is 5. Okay, then 2 cubed plus 1. 2 cubed is 8, plus 1 is 9. Okay, so then going backwards, it's kind of hard to see the pattern on that one because of that plus 1, isn't it? Okay, so we probably would want to do the 2 to the -1 plus 1. Anything to the negative turns it into a fraction. So we'd have 1 1/2 or 3/2. Okay, so I'll just put 1.5. Then 2 to the -2 becomes 1 over 2 squared, so it becomes 1/4 plus 1, which would be 1.25. Okay, 2 to the negative 3 would be 1 over 2 cubed, which would be 1 over 8 plus 1. And I believe that would be 1.125. Okay. Now if we do this one, that one should be easier, right? Negative 3 plus 3 is 0. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2. Then 3, then 4, 5, and 6. So looking at this, we can see they intersect right there. That's one of them, right? Then, okay, that's the easy one, so that'd be 2, 5 would be one solution. Now the other one, this one's smaller, right? And then it gets bigger. So somewhere in between here, these 2 points right here, it's gonna cross. So it'd be like, maybe we'd call it negative 1.5 and like 1.4 or something. Okay, something that would intersect between those two. Because we're just estimating. So we're just getting the idea of where they would intersect. Alright, number 8, we're going to do the same thing. Okay, so we take a table from negative 3. We have f of x, which is just x, so those numbers are exactly the same. And then we have g of x, which is 1/2 to the x. So 1/2 to the negative 3 actually ends up being 8. Because you flip the fraction and it's 2 over 1 cubed, so it's 8. I know it's kind of weird, these. So negative 1/2 to the negative 2 would be like 2 squared, so it would be 4. Okay, so now we're just cutting things in half each time, right? So that would be 2, that would be 1, that would be 1/2 or 0.5, 0.25, 0.125. Okay, so once again we look, do any numbers match exactly? No, so where do we see this idea of one being bigger? So this one's bigger, this one's bigger, this one's bigger, this one's bigger. Oh, now all of a sudden it's smaller. So right there, there's going to be one intersection. Okay. Then we look, and now this is staying bigger, and this one's getting smaller, right? So it looks like that's our only intersection point right now that I can see. I can't see one that would be another one. So, be somewhere in between the x value of 0 and the x value of 1, so maybe we'd say 0.5 for x. And the y value would be somewhere between 0 and 1 and 1 and 0.5, so maybe like 0.75 we'll guess. Okay, and that's the only solution I can see. Alright, 9. Marisol and Amy will go for a 5-mile run every Monday morning at 6 a.m. However, on one particular Monday, Amy was going to be 5 minutes late and asked Marisol if she would slow her pace so Amy would be able to catch up to her during the run. Marisol will run at 10 minutes per mile and Amy will start 5 minutes later running at 8 minutes per mile. The equations for the runners are given as follows. M of x is Marisol, A of x is Amy. Where x is in minutes from where Marisol starts her running, they're in miles, okay? Use a graph to find out how many minutes will have passed before Amy catches Marisol. Okay, so in other words, we're saying, when are these two going to intersect? Okay, so we're going to end up graphing these. Okay, so the first one is 1 over 10x. Okay, so it starts at 0. 1 over 10 means we go up 1 and we go to the right 10. Or we go down 1 and to the left 10. Okay, which doesn't really make sense according to our graph, does it? Okay, so our graph would look really slow and we may need to extend it. In fact, why don't we? Let's rearrange our graph there's 10. So that would be, after 10 minutes, she would be a mile. And then 2 miles after 20 minutes. Okay. The graph would look something like that, only less wavy. Okay, now we've got 1/8 times x minus 5. Okay, so that would actually be, if we multiplied 1/8x and then minus 5/8. Okay, well, what is 5/8? Let's use a calculator. Figure that one out. It's like 0.625. So a little over a -1/2 is where we'd start. So going down, we would start right here, and then when we go up 1, we go to the right 8. So it'd be right about here. Okay. And we'd have to keep going, wouldn't we? And we'd keep going with that, right? Now, what I've done here is using Desmos.com, a good graphing calculator. I typed in my two equations because honestly it's easier to graph with technology. And we get their intersection point right here at 25, so that would be 25 minutes. They would have both gone 2.5 miles, and the one would have caught up with the other one. Okay? That's really all it wanted you to do here. So, how many minutes? 25 minutes. And I can't well write 25 apparently. And 2.5 miles. Okay, 10. Tickets for the school play cost $10 for adults and $5 for students. 120 tickets were sold in all for $800. The equations for the total profit and total tickets are as follows. Clear myself some space. Okay, so we've got our two equations here, where x is the number of students and y is the number of adults. Graph the two equations. At what points do the graphs intersect? And what does that mean about the ticket sales? Okay, so x and y, x is students, y is adults. Okay, we'd graph these both, so I'm going to again type them into Desmos and pull that up for us, okay? Okay, so while I'm getting that pulled up, so the way to think about this is x plus y means students and adults together, added together, equaled 120. So the total number of people were 120 on this day. And with the cost, they paid $800 essentially. So by graphing this, we're going to figure out how many adults and how many students, if there's 120 tickets, can make $800. Okay, so when I graph it, our intersection point is here at 80/40. So thinking about x was students, so we had 80 students come to the play, and y is adults and 40 adults. Okay, together they spent $800. Okay, and there's 120 of them there. But that's what the 2 points mean, and there we go.